How's it going, everyone? Hope everyone's having a good day. So today we'll be talking about what the heck is an array in programming. So here's a quick definition. An array is a data structure, which you can think of as just a way to store data that stores data in buckets that are indexed. Okay, so what the heck does that mean? Okay, for example, you can see I have 5 packing boxes here, and we could store things inside these boxes. So this is very similar to what an array looks like inside a programming language. Okay, so we could store things inside each of these boxes, and these things that we store inside the boxes is going to be some kind of data, right? Okay, and arrays have a few rules that we need to follow. So the first rule is that the same type of data needs to be stored in the boxes when we declare the array or when we first create this array. So let's say we have these 5 boxes, and these 5 boxes are all for strings or something. So that means if we declare an array of type string, each one of these boxes needs to have only a string in it. You can't put like an integer or a decimal or some other object inside here. It has to be a string. Okay, so that's the first rule. Okay, the other rule is that the number of boxes is predefined when you create the array. What does that mean? So you can see I have 5 boxes defined here. Because I've created an array of size 5, that means the array can't be smaller or bigger than that inside your program. So once you declare it of size 5, it is size 5 forever, which also means I can declare an array of size 1 if I wanted. Or I could do it of size 10 or more. So you have to look at your programming language to see how big you can make an array, but I believe it's in the billions. That's how big you can make it. Okay, and the other part you need to know is that arrays are indexed. That means each box has its own number. So as you can see, 0 through 9. So when I want to reference box 4, it's always going to grab me this box. So one little confusing part is that they are 0 indexed. That means we start counting at the number 0. In normal life, we usually start counting 1, right? But in programming with arrays, we start with 0. So we have 0 through 9 boxes here, which is actually a length of 10, because there's actually 10 boxes, but we start with 0, so the last index here is 9, which means if we want to reference or grab the contents of this last box, we would have to do 9 as the index that we want to grab from. Okay, so what can we do with arrays? So we talked about we can store one type of data in them. We can loop over the array, so we can create a for loop or a while loop to loop and look at each element that's inside the array. And the third here is reference a specific index. I forgot to actually write it in the slide here. But reference a specific index if we want to grab the element that is in box number 4, which is actually 5. So you can grab it directly if you know the actual index, which sometimes you don't, so then you have to go through the entire array. Which leads me into when are arrays fast? Okay, so data structures all have different trade-offs, right? So let's look at what arrays give us. So arrays are fast when we can get the element from the beginning or the end. So if we want to reference the first element in the array, that's really fast because we already know that it's referenced to index 0. And we also know the length of the array because we've predefined the length, right? So we can also know what the last element is, element 3, and we can get that immediately without having to search through the entire array. And then also when we're getting indexes from a specific index, so let's say we know the data that we want to get is index 2, we can just retrieve that very quickly. And here I've written big O, which stands for big O notation, which is a way that programmers use to figure out how fast an algorithm can take, or how fast an operation on a data structure can take. So these two things are O of 1, or constant time in big O notation, which is the fastest operation that you can do. It's always the same amount of time to do any of these operations. So that's where arrays really shine. Okay, and then contrast when are arrays slow? So when you have to search through an entire array for an item. All right, so here's an example. Here is an array with 5 elements. Let's say the data we want is in index 2, but we don't know that beforehand. So what do? We have to search from the beginning all the way to the end until we find what we're looking for. So in that case, arrays are pretty slow because this could be, billions of items, and we'd have to search from the beginning, and in worst case the element that we want could be at the very end. Okay, so we have to search all the way through. So that is big O notation of linear time. So it's O with n, and n is the number of elements in the array here. That's worst case scenario for the runtime of this algorithm. Okay, that's it for our tutorial today. Thank you so much for watching. I hope that you understood the basics of arrays. Thanks a lot.